Okay, today, good morning everyone. Today we are going to discuss on solving the linear equations with some set of algorithm. We have an algorithm, we will see how to solve this linear equation. So before that we will see the basics of again the linear equations and the vectors. So let us hit back to our screen here. So let us take again simple two equations with two unknowns. So x minus 2y equal to 1 and 3x plus 2y is equal to 11. So I will not say this right now to simplify this. We'll just see the representation of this. We know when we solve this, we will get the answer as x equal to 3. So how do we solve this? So basically what we will do, we will cancel the y terms and then we will substitute back this x term and we find, then we'll get x term, then we'll substitute back this in equation 1 and we'll get y. So this is how we normally do it, right? So anyway, let it be. We'll keep it in the same way for as of now. So then we will get x equal to 3 and y is equal to 1, and when you plot this on the uh, x and y plane, then this is y and this is x plane. So if you do the marking here 1, 2 and 3, so then this line here, so this will be our x minus 2y, this line x minus 2y equal to 1, and whereas we have one more line here that is coming like this. So there is a point of intersection. This is x equal to 3 and this is y equal to 1. So this is nothing but it is 3x plus 2y equal to, sorry, this is not 1, this is 11. So this is equal to 11. So this is the point, and here this is nothing but y is equal to 1 point. So this is how, this is the row picture representation. Basically if we write here, so it is this kind of a diagram, we call it as a row picture diagram, row picture form. And the point meets at x equal to 3 and y equal to 1. So here the row picture shows the two lines meeting at a single point. If same thing, if we try to represent here in terms of column, then the column can be represented as x of 1 and 3 plus y of minus 2 and 2, which is equal to, we'll call this as 1 and 11, which is equal to b. This we already done it. Anyway, I'll just revise it. So it means that we know the value of x is equal to 3 and y is equal to 1 as we have solved it. So now it means that it is 3 times. So how do we read this is that, so let me clear this. So it means that 3 times the column 1 plus 1 time the column 2, and which is equal to, which is equal to b. So this is how we will read in case of a column. So then the column vector is represented, we have seen this even in the previous tutorial, that if we plot this on the plane, then we have the vectors that so it is 1 and 3. So 1 and 3 we will get somewhere here. If you divide it, so here there are 3 markings, so this is 1 and 3. So we can write this as 1, 3, and which is the other one, so minus 2 into minus 2 we will get somewhere here. So this is minus 2 and 2. So then the we have one more here, that is 3 times, so it means 3 times the column 1 plus 1 times the column 1, which is equal to b. So when we do that, so what do we get here is that we'll get here that finally we will get 3 and 9 here, that is 3 times the column 1. And if you add it, then finally we will get this as nothing but, we will get it somewhere here. This is our b, which is nothing but it is 1 and 11, something like this. So this is the column representation. So here the 3 is a scalar multiplication, and the coefficients are nothing but, if we try to represent this in terms of matrix, then in this case we have 1, minus 2 and 3 and 2 are our coefficients, and a matrix multiplication form if you want to write, so then we will write like this. This is 1, minus 2 and 3 and 2, and the unknowns will write it in a column, so that is x, y equals 1 and 11. So it means in generally we will write this as a into x equal to b. So x is nothing but this unknowns, which is written in the column form, we write it in time, we generally call it as x, and these coefficients are nothing but a, which is equal to b. So here our main interest is to find to solve the matrix by elimination process. So I'll just list out this, I'll just save this page. So let's list out few things here in the elimination of the matrix. The first one is that elimination goes from A to a triangular U by a sequence of matrix steps EIJ. So this is the first step. So it means we are the coefficients of A, that is the matrix which we had written, that we had a coefficients, and those coefficients we have to bring it in a form of a triangular, that is nothing but the upper triangular form, upper matrix form, with a sequence of steps EIJ. So that we will see. So then the inverse matrices E inverse of IJ, I'll write inverse as like this. So inverse in reverse order bring U back to original A. It means the inverse of the coefficient should bring back our original coefficient matrix, that is A. So then the third is that in matrix language, that reverse order is A is equal to L into U. So rather than going for the inverse of EIJ, so what we will do is that we will multiply this upper triangle matrix with the lower triangle matrix, so that we can get back our A, that is the coefficient matrix. So L is nothing but the lower triangle here, then U is nothing but our upper triangle matrix. Then fourth one is that my voice is not clear. Can you hear now? Hello? Hello? Can you hear me? Can you hear me now? I think it is audible. Hello? Okay. Okay, fine. I think there is a slight network issue. There is a breaking again. The audio has there is audio broke again. So let me open back that tutorial. So now what we are discussing is that I just started with two equations here, that is x minus 2y equal to 1 and 3x plus 2y is equal to 11. We know it's a simple way to solve is that we straight away we cancel y and then we'll get x and then substitute back x in the equation 1 here and you will get back your y. So this is normal way of solving it. Let's fine, it's okay, we will keep it in the same way for as of now. So then we'll get x equal to 3 and y is equal to 1. So then we plot on the then we plot on xy plane here. So then this is nothing but x minus 2y equal to 1 and the other one is, okay, it is not visible. So I have to select this, but sorry for that. Yes. Okay. So now it is visible. So here I have taken a simple equation of x minus 2y equal to 1 and 3x plus 2y equal to 11. So normally what we'll do, we'll cancel out the easiest term here, so y, and then we'll get back our x and then we'll get back our y by substituting the x. So if you plot this on the xy plane here, so this is the x minus 2y equal to 1 and we have the one more line here, that is 3x plus 2y equal to 11. So fine, and it meets at one point, so this is called as x equal to 3 and y is equal to 1. So this kind of the graph or the diagram, we call it as a row picture graph or the row picture representation. So if the same thing, if you want to represent in a column form, so then what we'll do, we will write the coefficients of x, that is 1 and 3, and we'll write the coefficient of y, that is minus 2 and 3, so which is equal to b, b, that is nothing but 1 and 11 on the right hand side. So this we call it as b. So please read this as b. Then again from this solution we have x equal to 3 and y equal to 1. So then we will write this as 3 times the column. So how do we read this vector form is that, so 3 times the column 1 plus 1 time the column 2 will result in the right hand side, that is b. So that is what this vector diagram that is written here. So if we have the vector diagram here on the plane, so 1 and 3, so 1 means on the horizontal side we'll move 1 step and vertically we'll move 3 steps, so we'll get a point 1 and 3, and minus 2 and 2 means we'll go 2 steps on the left from this 0, 0 point, and then we'll move 2 step upwards. So this is our minus 2 and 2, and then we have 3 times the x1, so we'll get 3 and 9. So we'll move 3 steps in the horizontal and 9 steps in the vertical, so we'll get one more point here. So likewise we'll get one more arrow here, so this is arrow is b, that is at 1 and 11. So then if you want to represent these vectors in a matrix form, so then we'll write this as 1, so we'll write the coefficients here, that is 1, minus 2, 3 and 2. So into x, y equals to 1 and 1, 11. So here these coefficients we call it as a, and these unknowns, generally please do not get confused with this x and this x. So these are x and y are the unknowns, but here we generally represent that vector or the column of the matrix as x, which is equal to b. So this was what we are discussing. So now let us continue with our discussion here. So then we have there are quite steps to solve this in a proper way. So that is I was writing here. So our main intention is to solve this matrix, and rather than having a very vague method, so we should have an algorithm which should be applicable for any kind of equations or for n number of equations with n unknowns. So for that we'll go for an algorithm so that states, so here what it states is that so first step is that elimination goes from A to triangle U. It means the coefficient matrix what we have represented A, we have to bring it in a form of upper triangular matrix form by the sequence of steps, that is Eij. So it means we have to remove the other below the diagonal part of the A matrix to make it 0, and then we have to bring it in the upper triangular form, and then we have to bring it back by using inverse method so that we can get back our A. Otherwise we can also do it like in a matrix language, that reverse order we can obtain it as A equal to L into U. So it means L is our lower matrix, lower triangular matrix. So if you multiply lower triangular matrix with the upper triangular matrix, we'll get back our A. So that is what we're writing. Now let me write the fourth step here. The fourth point is that so then elimination succeeds if A is invertible. It means that the elimination process will be successful only if it has an inverse of A matrix. Okay, so these are the points which we have to remember it. So there is also a 3 cross 3 matrix. I'll not go right now in the representation, that you can write and understand of it. So now we'll talk about this elimination matrix. So idea of elimination. Let me save this page here. Right. So the idea of elimination, this is very important. How do we eliminate? So just let me take the same equations again, the two equations which I had written, that is x minus 2y equal to 1, and 3x and 3x plus 2y equal to 11. Let me clearly write this. So it is x minus 2y equal to 1. So now the step is that we have to bring this. Now if I write these coefficients here, so the coefficients are 1, minus 2, 3 and 2. So I have to bring this in these coefficients or the matrix in a triangular form. So how to do that? So always there is a algorithm. So this, whatever this first this unknown we have, if you talk in terms of the row, there is a first unknown should be multiplied with some multiplier, so that I should get this second one, so that I can remove this. Now for example here the multiplier is nothing but the 3, so it means I call this multiplier as equal to 3. So now I'm going to multiply this with the pivot. I'll tell you what is this pivot. So when we multiply this 3 with the equation 1, so algorithm just goes like this. So then what do I get here? So 3x minus 3 to the 6 y equal to, I'll get 3 here. Then I'm going to subtract this with the second equation. So when I subtract this with the second equation, so it means that is 3x plus 2y equal to 11, and I'll write here that is 3x minus 6y equal to 3. Now let us subtract this, change the sign here, and we subtract it. So finally we will get this. So x will get cancelled. So for y we will get this as 8y equal to 8. So this is our now new row equation. If you look here, so this is our new row equation, which is very important to get it. So now if I write this again, if I rewrite our matrix, if you look into our matrix equations here, that is x minus 2y equal to 1 and 3x plus 2y equal to 11. Now our new form after this is that, so the first row will remain as it is, that is x minus 2y, and this is equal to 1, whereas the second equation will simplify to 8y equal to 8. So now if you see this, this is in a triangular form. So this is what we wanted. So it means, so now both the equations, if you plot on the row picture, it results in the same. So let us see that first and then we'll continue our discussion. So now if I plot these, I think I have enough space here. Yes, I have enough space. So I'll write it here. So for example, if I plot this on the 1, 2, 3 divisions, and this is one division here, so this is my y and this is my x. So if I take these two equations and if I plot it on the xy plane, so then I'll get like how we got for the previous one. I'll get something like this. So this is my x minus 2y equal to 1, right? So then we have the one more term here, so that is 3, we'll get like this. So this is my 3x plus 2y equal to 11, right? It means here it is meeting at the same point, that is at x equal to 3 and y is equal to 1. Fine. So it is meeting at the same point. Now let us come back to this equation. Now you solve these equations. So what is our y from this? So y is nothing but 1. And when you back substitute in this case, so what do we get here as x? So x we will get here as 3. Now if you look into both of these solutions, so in the normal way which we did previously for the same equations, we got the x equal to 3 and y is equal to 1. Now here after the elimination process, which we have applied a elimination algorithm, we got the triangular form. Even for this triangular equation, I am getting the same the points, the intersection points. Now if I plot this on this plane, xy plane again, then so this is my x and this is my y here. So then, so let us divide this into 3. So this is 1, 2 and 3 here. So I got this, so this is my y with 1, so then I'm getting this here. Then y is nothing but 1, it means a straight line like this. So this is nothing but our 8y equal to 8, so it means it is y is equal to 1, so I'll get a straight line. It's like a step signal. So and this is my x minus 2y equal to 1. So you see the point of intersection here. So where it meets, again it is 3 and 1 itself, where x equal to 3 and y equal to 1. It means the elimination will give the same results as how we do with the normal method. So here what we did is that, so we have subtracted a multiple of equation 1 from equation 2. So the main highlighting point here we have to understand is that we brought the system, so here the system becomes a triangular, and I want to highlight a few things here. So what is our multiplier in this case? So multiplier is L is equal to 3, so that is decided on what is there on the second equation. Second equation we have 3, so that will become our multiplier, and there is something called pivot of x in the first equation. So this is our first equation, and what is the pivot we have, means what is its coefficient? So its coefficient is 1. So this pivot cannot be 0. So this is one of the condition here. This pivot cannot be 0, and it has to be any value other than 0. So now we have the pivot, the first the number, the coefficient for which we are multiplying this multiplier, so that we call it as a pivot. So now the pivot is here, that is 1 for the first equation, and then when we multiply we got this triangular form. Alright, so hope you have understood this. Now let us take one more example here. I'll save this page. So let us take one more example. Now you tell me, now rather than 1x in the first equation, now it has become the 4x minus 8y equal to 4, and 3x plus 2y equal to 11. So now even the right hand side, so this is rather than 1 it has become 4, and here the coefficient of in the first equation, it has become 4. Now can you tell me what should be the multiplier value and what is the pivot in this case? I'll ask you. Can anybody answer this? Okay. So in this case, if you see the x here, so the coefficient of the first equation of x, so that is our pivot. So the pivot of this equation is 4 here, and the multiplier will remain to be same because the multiplier will depend on the second equation coefficient of the same unknown, that is x here, so that is 3. So now I have to remove this. So what should be my multiplier here? So if I want to remove this, so it should be in a form something like this. So now my multiplier will be that I have to take this L is equal to 3 by 4. Let's see how this will work out. So L is equal to this. Now my multiplier is 3 by 4. Now let us multiply these. Let me write the first equation here. Sorry, a second equation. So plus 2y equal to 11. So now I'll multiply this 3 by 4 to first equation. So what do I get here? So 4 and 4 get cancelled. So what do I get here? I'll get here as 3x. Then I'll get here, so it is 8. So even this y is changed in this case, so sorry, it is minus. So 4 and 2, so I'll get 2, so 3 to the 6, I'll get here 6y, which is equal to, now it is again 4 get cancels, I'll get here 3. So now let us subtract this equation. So what do we get here? So x get cancels, so here I'll get back my 8y, and again I'll get my the right hand side. I think I missed it something. Did I miss something here on the right side? So 4, I'll get 3, so I'm supposed to get 8. L, if I multiply this, so it is 3 by 4, so 4 get cancelled, so I'll get it as 3. So I'm supposed to get it as 2. So here I'll get back as minus 2. Did we miss something here? I'm supposed to get 8. How is that 8? I'll get here. So what are the equations on the right side? Is it 8 or 1? So now it is 4 and 8. So now I got here 8y, that is fine, but okay, sorry, this is what, 11. It's my mistake. I have written it as 1. It's my mistake. So it is 11. So 11 minus 3 is actually it is not minus 2, I'll get back my 8. So I see, even if we change the coefficients in the equation slightly, even we get back the same answer. Now if you write this, now what are our new equations? Now new equation is, the first equation will remain as it is, that is 4x minus 8y equal to 4, and the second equation, after eliminating, I'll get back my 8y equal to 8. So now if you look, this is again in a triangular form here. So this is in a triangular form. So what is my pivot in this case? So pivot is the first non-zero in the row that does the elimination. That is the definition of pivot. So let me write the definition of pivot here. Pivot is actually the first non-zero in the row that does the elimination. So that we call it as a pivot. And what is a multiplier? So multiplier is that term, that is the entry of eliminate that is divided by pivot. So in this case it is nothing but it is 3 by 4. So 3 by 4 is the multiplier. So hope you have understood this. And then once we get the y here, that is y equal to 1, then we substitute back. We'll go for a back substitution method, and then we'll get back our x. Yes. So this is a method. So now at some point there is a possibility that this method, whatever the elimination method we have discussed so far, it may break or it may fail. So there are many chances that it may fail. So let us take one example here which showcases the failure of this elimination process. So before that, let me save this. So page 62, new one. So let us take the one more equation here, that is x minus 2y equal to 1. This is the same equation as before. Now then 3x minus 6y equal to 11. Right. Now it is not same as 11, I think. Yeah. So let us take these equations. Now let us try to simplify with the elimination process. So I'll write the second equation as it is, so because I have to eliminate. So my multiplier in this case is 3. So L is equal to 3, and the pivot is L is equal to 3 and the pivot is 1. So I'll just multiply this 3 to 1. So I'll get to 3x minus, yes, this is a failure case. So minus 6y equal to 3. Now when we subtract this equation with the second equation, you see what do we get here? X will get cancelled, and also you look here, our y will become 0. It means it has become free of y equation. This is one of the case. It is a permanent failure with no solutions. So this example is a permanent failure with no solution. So elimination makes this clear. So now what we have is just if you plot this on the row axis, so then it means I'll just plot it on the right side. So if I plot this on x and y plane, I'll get the two straight lines which never meets. So that is what this equation, it means this doesn't have a common point of intersection. So if I write this, so I may get something like this. This is one line, so this is my x minus 2y equal to 1, and second line if I write here, so then I'll get something like this. So this is my 3x minus 6y equal to 11. So it means it will never meet and it will never have any solution for this case. So if you try to write this in terms of vector form, so the vector form looks in this way. This is the row picture. So if I write the column picture here, so the column picture also you should understand. So if you write in a vector form or a column form, column picture, so then we'll get here. So both these vectors are moving in the opposite direction. It will never. It is something like this, which will get. So columns do not combine to give B. So first one is that we have 1 and 3, and the second one is I think this goes like this. It is -2 -6 will come like this. So let us take the 2 steps here. So this might be 2 steps and this might be 6 steps. So this will be -2 -6. So it will come here, the vector. If we combine this, we will never get, we will not get, this is what it means. So this is the first column, that is 1 and 3. If we combine this, if we add this, we will not going to get even whatever the value of multiplier. If you multiply this with x and y, we will never get this b. So we will never get this solution. So that is what it means here. So it's a failure case here. So if we generalize this, so but still here one thing we have to note down is that still we have one pivot. So what is that one pivot? If I write this in a way, so let me write that here. So after this simplification we'll write back in this way. So x minus 2y equal to 1, and this is 0y which is equal to 0. So it means there is a one pivot, but it does not give me the solution. So if you see, we'll free, it means x is just 1. It means it's a kind of a step signal. That's it. So let us highlight few points here. Let me save this page. So page 63 here. So the points to be highlighted here is that the failure for a general case for n equation, we do not get n pivots. So basically we are supposed to get n pivots for n equations, but if this is the failure case, then we do not get the n pivots. And the elimination, if you look into elimination, will lead to an equation that is 0. I'll write below. So that will lead to 0, will not lead to 0, will give. Now in the previous case, if you see, we got the coefficient of y as 0, but on the right side it is not equal to 0. So it was 8, correct? So it was 8. So it means, so this kind of thing will not give the solution. So this has no solution. So this has no solution. Whereas for the other case, if 0, the coefficient of y, means after solving the second pivot which we get, if that is 0, and the right hand side if it is also equal to 0, it means that is 0y equal to 0. That is, it means we have many solutions. If it is 0y equal to 8, like the previous case, on the right hand side we had 8, but here we got 0y, it means this has no solution, whereas this will have many solutions. So if I write here, so for this case we'll have many solution case. So now let us look back a temporary failure example here. So I'll just clear the screen. Let us take one more example. 0x plus 2y equal to 4 and 3x minus 2y equal to 5. Now if you look into this case, the pivot, the first pivot cannot be 0. In this case, what we'll do, this is a temporary failure situation, so 0 in the pivot. So what we'll do, we'll go for a permutation method. So permutation is nothing but we're going to exchange the rows. So let us exchange the rows. Let us write like this. So 3x will bring back the second equation to first equation and first to second. So this is equal to y, and then we'll write the second equation here, that is 2y equal to 4. Now if you look into this case, it is already in a triangular form, so we need not to go for any of the elimination process. So it's in a triangular form. Now from this we'll get back this y is equal to 2, and then when we substitute back here x, we'll get the x equal to 3. We'll get x is equal to 3. So this is the temporary failure case. So now in this case, what happened here, the pivot is now the first pivot is equal to 3. So this is a temporary failure case. Now if you look into this, and if you plot this row picture, and not for this actually, that's fine. We are not going to write anything. So hope you have understood this temporary failure case, so where we are going to exchange the rows here. So fine then. So still we are in the basic introduction, which is very much required to understand the vector space. So once we are okay and familiar with all these concepts, then we will switch back to our vector space. So thank you.